All right. I've done this lesson already, integration, but I was focusing on the reverse chain rule. So now I'm changing this and use another technique, which is for this, I'm just going to use substitution. So we're going to do the same technique, integrating, but now not using the reverse chain rule, but by using the analytical method of substitution. So let us look at the various examples that we can do. So we have got functions that can be written in this form. I've explained more about that. So if we've got functions that can be written in this form, which means they are a quotient and the numerator is a derivative of the denominator, you can use the substitution rule. So we can quickly look at this function here. That it is in this form, there's no doubt. By that I'm referring to, if I differentiate x squared plus 1, I get 2x, which is actually the form of the numerator. So what we can do with substitution, we'll just say let u, we substitute the denominator to become u plus 1. And once we've done that, we are going to say du over dx is equal to 2x. And since we are substituting u for x, it means also dx has to change. So we have got to make dx, the sum of the formula here, it is identically equal to this part here. So that's our substitution. So this implies that we're going to have the integral of 2x over x squared plus 1, which is now our u, and dx changes to du over d2x. This is the reason why we're substituting, because we are simplifying this function, and it indeed looks like 1 over u with respect to u. And this type of functions, we know them already from differentiation. That is equivalent to natural log of u plus c, and again our u is x squared plus 1 plus c. All right. Next, we'll look at the second example, which is cos x. The integral of b is the integral of cos x over 2. I want to believe it's 2 over 2 so it is going to be over 2 over 3 plus 2 sine x. And again, a quick scan. Maybe let me just do this one. You can see that f of x is the denominator is 3 plus 2 sine x, and f prime of x is equal to 2 cos x, which I believe is in the form of that numerator, which is cos x. But there is a k, the value of 2 here. You can always adjust, but with substitution, you don't need to worry about that. As long as this is met, you can just say let u be equal to 3 plus 2 sine x, and du over dx, which is equal to 2 cos x. 2 cos x. So we can replace, this means we are going to have du over 2 cos x being identically equal to dx. So as a result, this leads us to what we want. So we have, this implies that this is going to be the integral of cos x divided by u, because that automatically becomes your u, and then we have du over 2 cos x, and this cos x and this cos x cancels. We are left with, so I would rather take these two outside the integral. Since it's a constant, it becomes 1 over u du. So our final answer is half natural log of u plus c. But remember, your u has been defined in terms of x, which is 3 plus 2 sine x. See? All right, this is a much easier way of integrating using substitution. Next, I think I've explained that already. We also have other functions that are products, but the product is arranged in this form. The product is arranged in this form. It can also be arranged. You can rearrange this one. You don't have to, it doesn't have to be this way all the time. So you should be flexible with your numbers. It doesn't change anything. So looking at that, a quick look at the first example. Here it tells us that this is our f of x, which is sine x. The derivative of sine x is just cos x. So this is in that form. A quick scan already. So what we're going to say is let u be equal to f of x, not f of x squared. You just look at f of x, which is sine x. So you're going to have du over dx, which is cos x. This tells you that du over cos x is identically equal to dx. You proceed with your substitution. This is going to be 3 cos x, but where there is sine, you now put u but squared, then you have du over cos x. So this simplifies the equation. So we are going to have 3 u squared du, which is just 3 u to the power of 3 over 3 plus c, which is equal to this 3 and this 3 cancels. We have u3 plus c. And u was sine, so that's going to be sine cubed x plus c. That's substitution. Take some moments and try to do B. You can pause the video and do B. Right, let us look at it. B says the integral of f of x, the integral of x, and then we've got x squared plus 5 squared dx. Clearly, this is our f of x, which is squared, the higher power. And if we differentiate it, we get 2x, which is in the form of the linear as x. So we can simply say let u be equal to x squared, because it's going to cancel x anyway. And then du, you don't really need to keep doing this. Du, if I differentiate the a, is 2x, so it's du over dx. So then we can go to 2x to dx. This is what I want to substitute for. So this is the same as saying x u squared du over 2x, of which the x and the x cancel. We are left with half integral of u squared du, which is equal to 1 over 2 times, I'm working ahead, plus 1 here, that's 3, 1 over 3, u3 plus c, and our final answer is 1 over 6, u3, which is equal to x squared plus 5 squared plus c. Alright, next example will be slightly above here. Again, we have got the same scenario. 2 plus cot x is a direct derivative of cos x squared. So if I say let u be equal to 2 plus cot x du over dx, which is going to be minus, not 2, minus cosec squared x. You don't really need to do the derivative of cot x because I believe it's found in the formula. So that means du over minus cosec squared x is identical equal to dx. So we can say the integral is equal to cosec squared x over u to the power of 3, and then du minus cosec squared x, of which these 2 and these 2 cancel. We are left with minus outside, 1 over u to the power of 3 du, which you should just write as u to the power of minus 3 du, and your final answer is minus. You add 1 here, you get minus 2, so it's minus 2 over minus 2 plus c. You're going to get the final answer is 1 over 2 u to the power of minus 2 plus c, which is simply 1 over 2 u, which is equivalent to, what was my u? 2 plus cot x. So it's 2 plus cot x, 2 plus cot x plus c. Substitution kind of moves a bit more faster. I can let you pause the video as well, do this question and see how it goes. But clearly you can see the derivative of sec x is sec x tan x. So we have that, so we can simply say let u be equal to sec x, and du over dx is sec x tan x, which means du over sec x tan x is equivalent to dx. Substituting that gives us the derivative of c of theta here, 0 here. I always prefer to put the 5 outside and have tan x here, and then I have u to the power of 4, then I have du over sec x and tan x, and this tan and this 10 cancels. Remember, sec is already u here, so if I put a u here, it simply means I have okay, this should be, this implies, because this is equal to 15 over 4. So we should have 5 here, integral of u, this is your u, it's also another u, let's put it here, u. So you're going to have u to the power of 3 du is equal to 15 over 4. And you integrate again, you get 5 over 4 u to the power of 4 is equal to 15 over 4. These values are in terms of x, it's theta and 0, theta and 0. So you have to revert back to x because u is what? What is u? Is sec x. So we are actually going to say this is 5 over 4 sec to the power of 4x. Theta and 0 is equal to 15 over 4. So once we've done that, I want to believe it is much straightforward to simplify this, because if I put theta here, I'm going to have 5 over 4 sec to the power of theta. If I put 0, this is just going to be 5 over 4, because cos sec is 1 over cos 0 is 1, so it's just going to be, which is equal to 15 over 4. So you've got an equation already that is looking very good to simplify. 5 over 4 sec to the power of 4 theta. If this goes there, is 20 over 4. So we are fine. We will eventually be left with sec 4 theta is equal to what? Is equal to 4. Yeah. So this looks like special angles to me. This is going to be sec theta is plus or minus root of 2. And that's a special angle, because now 1 over cos theta is simply flat 1 over root 2, which is just pi over 4. According to the restriction set by the domain, which says theta. So that's our answer. So that's how substitution works. Again, you can still see this one. The fact that this is a derivative of the inside function, I can still say let u be equal to x cubed plus 5x squared plus 9 and du over dx. So that cancels this derivative. It's 3x squared plus 10x. So du over 3x squared plus 10x is identically equal to dx. This takes us to this part here, which is going to be equal to 0, 3. Keep 3x squared plus 10x. We put u here to the power of half. We put du There must be a dx here for it to be correct, to be in terms of notation. Over what? Over 3x squared plus 10x. These two cancels. So we are just evaluating from 3 to 0 u to the power of half. Du plus 1 here, that's 3 over 2. So that's going to be 2 over 3 u, 3 over 2 from 3 to 0. So this is going to give us 2 over 3 u is x cubed plus 5x plus 9 to the power of 3 over 2 in the range of 3 and 0. So we place the values. You can finish it off. 3 is going to be 2 over 3 here. This is 27. This is 9 times 45 plus 9 minus 2 over 3. Place a 0 here. Everything else becomes 0 and 9. You're free to use the calculator, but it seems like everything else cancels. The 9 cancels, and then 2 over 3. I will have to add 45 plus 27, which is 60. 772. You're free to simplify again. This is 2 here, carry 1, 4 here. So the 3 goes, well, the answer is just 48. Right? Substitution works all the time. Another one is 3x, 1 minus cos 3x. As you can see, this criteria has been satisfied by quickly inspecting. The denominator gives you the derivative of the numerator. So you can simply say let u be equal to 1 minus cos 3x, and du over dx is equal to minus, so that's minus here, that's negative, cancels each other, 3 sine 3x, function within a function. So the chain rule is very important. So du is over 3 sine 3x, replaces dx like this. So we're going to have the integral of 2. This implies that 2 pi over 9, pi over 9, and I'm going to have 6 sine 3x divided by u, then du over 3 sine 3x, and these two guys cancel. There's a 2 here. We're going to have 1 over u du. So this gives us 2 natural log of u plus c. We just quickly check again what was u, 1 minus 3 cos x, and then we have 2 pi over 9. So this is going to be equal to 2 1 minus 3 cos 3x, and there's 2 pi over 9, and there's pi over 9. Yeah. Okay, there's no 3 here. Just to confirm the 3 is not here. Right, so substituting the values becomes easier because we can see these are special angles. If I put 2 pi over 9 here, the 3 cancels that, that's 2 pi 3. So I'm going to have 2 natural log of 1 minus cos 2 pi 3 minus 2 natural log of 1 minus cos pi over 3. So these are special angles, simple to simplify. Cos 2 pi over 3, that's special angle of 60 degrees. Yeah, and cos 60 degrees is half. In the second quadrant is negative, so that's just going to be 2 natural log of 1 minus half minus 2 natural log of 1 minus half. That's how it goes. Just do it here. This is equal to 2 natural log of 3 over 2 minus 2 natural log of half. You can apply the rules. That's 2 again, They divide each other, so okay, that's just natural log of 3. Your answer is done by substitution. Right. Next question. Again, quickly check that this is cos x over sine x. So if we say let u be equal to sine x, du over dx is cos x. So du over cos x is dx. To find this is equal to the integral of sine over u, cos over u. So that's going to be cos x over u times du over cos x. These two cancel, we're just going to have 1 over u. Du, which is equal to natural log of u, plus c, which is equal to natural log of, what's my u? Sine x. So substitution is much quicker than the first chain rule. I will leave you to go through this question by substitution again. You pause the video. However, what we know is tan x is equal to sine x over cos x, and that's exactly the same part, which is that. So this technique is quite very effective. So let us have u be equal to cos x. So du over minus sine x is equal to dx. I've just left one line that you should identify, because the derivative of cos is minus sine. So this is going to be equal to the integral of sine over u, the sine x over u, with du over minus sine x. And this guy cancels. We are left with minus 1 over u. Du is minus natural log of u plus c. This is minus natural log of u, which is sine cos x, plus c. So technically that's our final answer, but to take it to sec, it is just a matter of saying this is natural log of cos minus 1x plus c, of which this is equal to natural log of 1 over cos x plus c, which is equal to the natural log of sec x plus c. Is it correct? All right. Thank you for watching my video.